This is your 2.1.2 notes for Integrated Math 2. Our learning target is I can identify similar triangles using triangle similarity shortcut theorems. Angle, angle, side, 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 and side, angle, side. First off, we have similar triangles when we have all three corresponding angles are congruent and all three corresponding sides are proportional. So corresponding angles here, angle A is 85 degrees, angle D here is 85 degrees, those correspond. Our smallest angle here is angle C, which is 40 degrees. Angle F here is 40 degrees, those correspond. Our mid-size angle is angle B, which is 55 degrees, and angle E, which is 55 degrees. So in this case, all three corresponding angles are congruent. Then the three corresponding sides must be proportional. This is different from triangle congruence, where they're the same. The corresponding sides are the same measure. For similarity, they're proportional. So what does that mean? So if we take a look at the largest side, what's the largest side here? The 40. What's the largest side of this triangle? It's the 10. So if I want to look at the ratio of similarity of those sides, the longest side, I can go large over small, and I have 40 over 10, which is 4 over 1, or just 4. Okay? Then I need that same ratio of similarity for the other two sides. Let's see if we have that. If I look at my smallest side is 20. My smallest side here is 5. Those are the corresponding sides. So if I did the ratio 20 over 5, I also get 4 over 1. Finally, if I look at my other side that we have here, the 36 and the 9 correspond to each other. And if we look at the ratio of 36 over 9, I also get 4 over 1. So we would say here that the sides are all proportional. They all share the same ratio, 4 to 1, when you put large over small. Now, there's no rule that says you have to put large over small. We could have went small over large. In that case, we would have got 1/4 each time. 1/4, 1/4, 1/4. Now, we have pretty easy ratios here. But sometimes you might get some ugly fractions. Maybe you get 3/17. And you're like, and then you get another one that's a different value that is not 17ths. How do you know if they're the same? Well, you simply take the numerator and divide it by the denominator on your calculator, and that gives you the number. So 4 over 1 is 4, but if I had it as 1 over 4, it'd be 0.25. So you can always use your calculator to get the ratio as well, especially for students that aren't big fans of fractions and you need to be able to reduce them, and that's not your thing, not your forte. Fine, use your calculator. All right, first one. Angle, angle, triangle similarity theorem. What this says is if we have two corresponding angles are congruent, then the triangles are similar. That's our shortcut. So we look at here, we have triangle ABC and triangle ADE. We have parallel segments. So what that gives us some information. We know from previous units that corresponding angles are congruent when these segments or lines are parallel. So in this case, angle ABC is congruent with angle ADE because corresponding angles theorem. Same thing here. We know that angle ACB corresponds to angle AED, so those are also congruent since these are parallel. So that's enough information now to tell us that these triangles are similar. So we can say that triangle ABC is similar to triangle ADE, and why? Angle, angle, triangle similarity. Now, in this case, we would also know the third angle here would be congruent to itself because they share angle A. And we also know from triangle sum theorem that once two corresponding angles are congruent, the third angle must be congruent because the sum of the interior angles always has to add up to 180 degrees. So that's why we only need two angles. And then in class, some students asked about what about angle side angle, because that was a triangle congruence theorem. We do not need angle side angle for similarity because we can just live with just angle angle. So why make it more difficult than it needs to be? Just angle angle. You don't need the side. All right, the next theorem is side-side-side triangle similarity theorem. And this is slightly different than side-side-side triangle congruence theorem because we're talking about the sides being proportional, not the sides being congruent. So we got to look at the corresponding sides. So corresponding side to corresponding side. The largest side here is 8, so 8 corresponds to the 4. The smallest side is 4, so 4 corresponds, small side here is the 2. The next side is the 6, corresponds with the 3. So now, in order to say side-side-side triangle similarity, we've got to prove that the ratios are all the same for all those 3 corresponding sides. So to do that, we can write it either small over big or big over small. In this example, we're going to go the small over the large. So if I look at 4 over 8, that was this one right here, and it gives us 1/2, or if you use your calculator, 0.5. I look at the 2 over 4, that gives us 1/2, or 0.5. And then I look at the 3 over 6. 3 over 6 is 1/2, or 0.5 as a decimal. So we have a ratio similarity that's consistent. Again, you must be consistent. Are you going small over big, or are you going big over small each time? You must be consistent with that. All right, so in this case, our triangles are similar because we have the ratio similarity of 1/2. So we can say that triangle ABC is similar to triangle DEF. Okay, and the reason, justification is side, 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 triangle similarity. Again, you must give me the ratio similarity. You must show that work. You can't just look at triangles and say, well, this gave us a side, so I think it's side, side, side. Sometimes you might be right, but you gotta justify it, you gotta prove it. Okay? All right, last one is side angle side triangle similarity. And so this is where we have an included angle that's congruent. So in this case, angle A is congruent to angle D. And then we have 2 sides that make up the rays of the angle. They're on top of the rays of the angle, if you will. So we have this side here is on top of this ray, this side's on top of that ray, and same thing here. So we gotta then look at the ratio of those sides and see if they are proportional. So again, we're gonna put large over large, so my 9, 3. So I'm gonna go 9 over 3 equals 3 over 1. And then I can go 6 over 2 equals 3 over 1. So those ratios are the same, and I had the included angle in between it, so I can say now that these triangles are similar. So I'm going to say triangle ABC is similar to triangle DEF. And our justification is side, angle, side, triangle similarity. Okay, and the way they did it here in the book, they actually did the same thing, but I want you to see this. They went small over large, so see how they got 1/3, 1/3 versus our 3, 3 here. It doesn't matter which way you drive. You can drive whatever you like. So again, if you're using a calculator, you would have gone 1 divided by 3, you would have got 0.33, and 1 divided by 3, you would have got 0.33, or if you went 2 divided by 6, or 3 divided by 9. So you can use your calculator to get the decimal for the ratio if you like. That's it for this topic. Thanks for taking down your notes.